Okay, it's time to start the next unit, which is waves. And really we're going to break this unit into three sections. The first will be like waves in general, and it will be terms that will apply to all different types of waves, almost like definitions. The second section will be sound, which is one particular kind of wave, and the third will be light, another type of wave. Okay? So in this beginning part, then, it's going to be a lot of general terms that will refer to sound waves, light waves, but also water waves, earthquake waves, all the different types of waves you can imagine. Okay? So to start with, you need to think of a material that a wave's going to travel through. Now, the material that a wave travels through has a special name. It's called a medium. Plural for medium is media. So, like if we're talking about a water wave, then the medium through which the water wave travels, you're never going to guess what it is. It's water. Right now, as I'm speaking, my voice is making sound waves, and the medium through which they're traveling is the air. When light comes from the sun to the earth, comes into our atmosphere, again, it's traveling through air. If you happen to be swimming underwater, it might be traveling through water. If I create a sound wave by tapping on a piece of paper, and if I were to put my ear to the paper, the sound could be traveling through the paper. The medium is the paper. Okay, so the word medium then just refers to the material through which a wave is traveling. Like I said a minute ago, its plural is media, and if you think about it, media that we use today, that word media, it's like newspapers, television. It's the news, it's the network through which news travels. The same idea in physics, it's just the network through which waves travel. Okay, so if this is some material, if there's no wave passing through, then we say it's in its equilibrium or rest position. Okay? And a wave is really, it occurs because I'm going to imagine that we have in our rest position a whole bunch of little molecules lining up here. Okay? And if this molecule, this particle, begins to vibrate back and forth about its rest position, that's how a wave starts, right? This guy vibrates, and then it makes the one beside him vibrate, and he's not quite in sync because the first one started first, and then the one beside him vibrates, and then the next one. And so the vibration gets passed down through the medium so that the molecules are vibrating about their rest position or their equilibrium position. And remember, we used that word when we were talking about the spring oscillating. The spring was really following wave motion there. Okay, so as the vibration is passed through the medium, we say that it's propagating. You should be looking where I'm writing. Propagating. And I'm sure you've heard the word propagation or propaganda, right? It means the traveling through something. Propaganda is like spreading rumors or spreading lies or something through a medium, actually, like a newspaper. Okay, so it's all, the words are the same no matter which discipline you're using here. Okay, so when we define a wave then, we just say it's a vibratory disturbance that propagates through a medium. Okay, a vibratory disturbance that propagates through a medium. Now, I have to do something to create this vibratory disturbance. If you imagine that this is water, like maybe you have your dishpan filled with water, or maybe your bathtub filled with water, and then you take your finger and you just move it up and down. Your finger then becomes the source of the thing that's creating the wave, right? And so Once I move my finger up and down, then the disturbance spreads out. Here it's just in a line, but you should be able to imagine that if it was in your bathtub, it would be moving out in all directions. Okay? So a vibratory disturbance that spreads out or propagates through a medium. Now, the wave carries energy only. We often think that a wave carries matter. Like, think of a water wave. If you think of a water wave in the ocean, people always say, no, the wave's carrying water. But if it really was carrying water, the whole ocean would end up on the beach. The wave is really only carrying the energy, and the water molecules are just moving back and forth about a rest position. Okay, we'll come back to that again because you're probably thinking, what? I don't believe it. Okay, so a wave is a vibratory disturbance that is moving back and forth. You'll often also hear of a wave pulse, or sometimes we just call it a pulse. And so a wave is an up and down, right? A pulse is just one, either an up or a down. So if we go back to my finger in the bathtub, a pulse would be me just putting my finger in, right? So if I just put it in, it does one single disturbance. If I pull it back out, then it does the other one, and that's when you get a full wave. So an in and an out, a full cycle will give you a wave, but only a half cycle will give you what's called a pulse. Okay? So we'll be looking at what are called periodic waves. And periodic waves then are when the disturbance repeats itself over and over again in an equal period of time. So it's like stringing these waves or these pulses together in a whole string. Okay? So at regular intervals, the time period stays the same. All right, so now we're going to categorize waves, and we're going to do it in a couple of different ways. It's kind of like if we were to take all of you in the class, I could break you into different types, different categories based on characteristics. So I could say, okay, everybody who's over 5 feet 7 inches tall, stand on one side of the classroom, and everybody who's that tall or under, stand on the opposite side. And so I would have categorized you into taller or shorter, okay? But then I could put you all back together, and I could do anybody with long hair on one side of the classroom and anyone with short hair on the other side. And it wouldn't be the same groups of people, right? Like, so we're going to break our waves into we're going to put them in categories, and we're going to do it based on two different characteristics. So we'll talk about types of waves based on one characteristic, and then types of waves based on another. So the first one, it has two major wave types based on what they move through. Based on what they move through. Okay? So the first one in this categorization is called mechanical waves. Mechanical waves. And these are waves that need matter to move. They cannot travel in a vacuum, in empty space. They can only travel if there's matter there. Examples of these waves would be water waves. Really hard for a water wave to travel if there's no water. Sound waves is another example. Okay, sound will not travel in a vacuum. If your friends throw you out of the spaceship in outer space, don't bother yelling for help. No one's going to hear you. Sound waves need molecules. These mechanical waves, then, because they need molecules, they travel best, and by best I mean fastest.